All right, so let's talk about solving one-step equations by multiplication. So problem number 1 says the temperature fell a total of 10 degrees over 2 days. If the change in temperature was the same both days, how much did the temperature fall each day? And they gave us our equation here of 2x equals negative 10. So again, x is our change in temperature for each day, 2 is the amount of days, negative 10 was our total change here. So I'm actually going to start with the algebraic this time, because I think this is how our brain typically sees things as algebraically. So I'm going to rewrite my equation. So 2x equals negative 10. Since I'm solving this algebraically, I'm going to go ahead and build my t-chart. And then remember, my whole goal of one-step equations is to isolate the variable or to get rid of what's bothering the x. So again, I'm looking for a number and an operation that's bothering the x. So what's happening here is I am multiplying by 2. That's what's bothering the x. So I need to do the opposite operation. So the opposite of multiplying by 2 would be dividing by 2. What I do to one side, I have to do to the other side. So my times 2 and my divided by 2 are going to cancel each other out. So all that remains is x. And then I have negative 10 divided by 2. So a negative divided by a positive is going to give me a negative, and 10 divided by 2 is 5. So the temperature fell 5 degrees every single day. So let's talk about what this looks like with tiles. So remember, just a quick recap. My X tiles are these long, skinny tiles. My unit tiles are the small ones. Sometimes they're circles. I typically do circles just because they're faster to draw. Now, if they're unshaded, that's positive. But if I were to shade them in, that would represent a negative. Okay, so let's talk about our multiplication tiles. So when we have a multiplication equation, I want you to think of your X's as team captains. So when you're outside at recess or maybe your sports, I also don't think I spelled captains right, but that's okay. Anytime you're playing a sport, you're playing a game where you have to divide into teams and you pick a team captain, how it typically works is one team captain picks a player and then the next team captain picks their player. And then it goes back to the first team captain. They pick another player. Second team captain picks another, and they keep switching off until every person has been picked. That's how it stays fair because they're getting to switch off and it stays equal. They're all getting the same amount of people. So our X's are like our team captains. So in this problem, I've got 2 team captains. So I'm going to draw my team captains sideways. Oop, I guess not there. Just to kind of give myself some more room. They're positive captains, so I'm going to leave them unshaded, and they're having to pick between 10 negative tiles. So my first team captain gets 1 negative. My second team captain gets a second negative. So that's 2 in total. I go back to the first one for 3, second one for 4, top for 5, bottom for 6, top for 7, bottom for 8, top for 9, bottom for 10. So they've split those players evenly. My answer is going to be what just one of those X tiles is worth. So one X tile is equal to 5 negative tiles. So X equals negative 5. I'm going to check this by rewriting my original equation. So 2X equals negative 10. I'm going to substitute in what I think X is. So it'd be negative 5. So I have a positive times a negative gives me a negative. 2 times 5 is 10. So negative 10 equals negative 10. Check. On my graph, I'm just going to put a line. I'm going to call it negative 5, and then I want a nice closed dot on negative 5. All right, let's try another one. Our next one says, they just gave us the equation on this one. They went right to it. So negative 3x equals 9. So let's start with this algebraically. So negative 3x is equal to 9. I'm going to build my t-chart. And again, my goal is to get rid of what's bothering the x. Remember, that's a number and an operation. So I'm multiplying by negative 3. So I need to do just the opposite operation, which would be dividing and keep the number the same. So I'm going to divide both sides by negative 3 because what I do on one side, I have to do on the other side. Put parentheses around that so it looks like a negative 3. So my times negative 3 and divided by negative 3, they cancel each other out. So what remains is x equals, And then I have 9 divided by -3. This is a positive divided by a negative, gives me a negative. And 9 divided by 3 is 3. So I should get that x equals -3. So let's see what this looks like with tiles. So when I look on the left side, I have 3 negative team captains. So I've got 1. I'm going to shade them in to show they're negative. 2, 3. And they're going to split those 9 positive tiles. So remember, I'm going to start with the first one. So that's 1. Second one gets 1. Third one gets 1 for a total of 3. Back to the top for 4, 5, 6. Back to the top for 7, 8, 9. Now again, I just want to look and see what 1x is equal to. And when I look at this, I see that -x equals +3. But I don't ever want to put a final answer with a -x value. I need to turn this into a +x. So if I turn this, the opposite of -x would be +x. So I have to do the opposite of my answer. So the opposite of +3 would be -3. So on both occasions, we get +x equals -3. So let's do our check. I'm going to rewrite my equation. -3x equals 9. I'm going to substitute in what I think x is. So -3 times -3. A negative times a negative will give me a positive. So -3 times -3 is 9 equals 9. Check, that is correct. And then on my graph, I'm going to put just a line. I'm going to call it -3, and it gets a nice closed dot. On the back, it says Darius has 9 Hershey's Candies bars, and he wants to share them evenly between his 4 closest friends. What is x? The amount of candy that each friend will receive. So they gave us our equation, 4x equals 9. Let's start algebraically. So 4x equals 9. I'm going to build my t-chart. And again, I need to get rid of what's bothering the x. I need to isolate that variable. So what's bothering x right now is times 4. So the opposite of multiplying by 4 would be dividing by 4. What I do to one side, I have to do to the other side. My multiplying and dividing are going to cancel each other out. So all that remains is x equals, and then 9 divided by 4. 4 is going to go into 9 a total of 2 times, because 4 times 2 is 8. So what would be left over is 1/4. So I get x is equal to 2 1/4. So let's do this with our tiles. On the left side, I have 4x tiles, or 4 team captains. So there's 1, 2, 3, 4. And then they're going to split those 9 players. So for the top, 1, 2, 3, 4. Back up to the first captain, 5, 6, 7, 8. So they can all evenly share those 8, but then I have that 1 that is left over. Now I know this is going to sound weird because we're talking about team captains and players, and we normally don't split human beings in real life. That's just messy, and it's called murder. We don't want to do that. But in this hypothetical instance, I have this last player that needs to get divided between these 4 team captains. So if I have 4 team captains, I'm going to split my poor player into fourths, and each team captain gets 1/4 of that player. Hopefully it's the good fourth. So again, I just want to look at 1x value, and I get 1x equals 2 1/4. Please don't split your friends in real life. It's not the point of this. So let's go to our check. So I have 4x equals 9. I'm going to substitute in what I think x is, and I'm going to turn it into a decimal because I like to multiply with decimals better. 4 times 2 25/100 is 9 equals 9. Check. And then for my graph, I'm going to put one single line. I'm going to call it 2 1/4, and I'm going to put a nice closed dot on it. Okay, so now let's talk about what it looks like to solve one-step equations with dividing. So it says that Alyssa checked out some library books. 1/4 of the books were mysteries. If she checked out 3 mystery books, what is x, the total number of books she checked out? Now we know that when we see a fraction next to the word of, that is a sign that this is multiplication. And sure enough, when I look at my expression or my equation here, it says 1/4 x, which is 1/4 times x equals 3. But you might be thinking, Ms. Smith, this is dividing, so why is this multiplication? So here's what we have to think about. When I'm multiplying like this with a fraction, if I was going to get rid of what was bothering x, right now times 1/4 is bothering x. So the opposite would be divided by 1/4. But here's what tends to happen. When we divide with fractions, we know that dividing fractions is easy as pie. Just flip the second and multiply. But what happens a lot is people forget to flip that fraction when we're dealing with these one-step equations. And it just creates this extra step, all of this work. So I'm going to make your lives a little bit easier today. So when you see a fraction, 1/4 x, what you can do is you can take the x and you can put it next to your numerator. So this would look like 1x divided by 4 equals 3. Now, 1x, we don't really ever say 1x, we just say it as x. So I can rewrite this as x divided by 4 equals 3. So now when I have an equation that looks like this, we're going to look at this algebraically. X divided by 4 equals 3. I'm going to build my t-chart. And then I need to get rid of what's bothering the x. So what's bothering the x right now is this divided by 4. So the opposite of dividing by 4 would be multiplying by 4. What I do to one side, I have to do to the other side. These 4s are going to cancel each other out. So what remains is x, and then 3 times 4, which is 12. Okay, so let's talk about what this would look like with our tiles. So what this is saying is I'm taking one x tile and I'm splitting it into 4 pieces. So I'm going to draw a big x tile just so that gives me enough room. And I'm going to split it into 4 pieces. And then what it's saying is just one of those 4 pieces is equal to 3 positive tiles. So if one of those 4 pieces is equal to 3 tiles, that means the second fourth is also equal to 3 positive tiles. And the third fourth is also equal to 3 positive tiles. And so is the fourth fourth. So my entire x tile, when I add all of these together, is equal to 3, 6, 9, 12 pieces. So if I was going to check, I'm going to rewrite my equation. X divided by 4 equals 3. I'm going to substitute in what I think x is. So 12 divided by 4 equals 3. And sure enough, 12 divided by 4 is 3. So 3 equals 3. And we get a check. For my graph, I'm going to put a line. I'm going to call it 12 because that's what I think x is. And I'm going to put a nice solid closed dot on there. Our next problem says Susan made several batches of cookies for her daughter's birthday. 1/5 of the batches, which again we know means multiplication, were chocolate chip. And if she baked 9 batches of chocolate chip cookies, what is x? The total number of batches that she baked. So again, when I look at this equation right here, sure enough, I have 1/5 times x, but I'm going to rewrite this. So I'm going to put the x as my numerator. So x divided by 5. And again, I can do that because my numerator is 1. So x divided by 5 equals 9. So let's solve this algebraically. I'm going to build my t-chart. I'm going to circle what's bothering the x. So that would be divided by 5. The opposite of dividing by 5 is multiplying by 5. What I do to one side, I have to do to the other side. So my divided by 5 and my times 5 cancel each other out. So what remains is x equals, and 9 times 5 is 45. So checking this with our tiles, again, this is saying I'm taking one x piece and I'm breaking it into 5 pieces. So I'm going to give myself a big X just so I got some room. I'm going to divide it into 5 pieces. So there's 1, 2, 3, 4, 5. And again, one of those pieces is equal to 9. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. And if this fifth is equal to 9, then so is this next fifth. 1, 2, 3, 4, 5, 6, 7, 8, 9. So is the third fifth. 1, 2, 3, 4, 5, 6, 7, 8, 9. So is the fourth fifth. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so is the last fifth. 2, 3, 4, 5, 6, 7, 8, 9. Now again, I want to look at my entire X tile. So my entire X tile is equal to 9, 18, 27, 36, 45. So if I was going to check this, I can go back to my original equation of X divided by 5 is equal to 9. I'm going to substitute in what I think X is. So 45 divided by 5 is equal to 9. 45 divided by 5 is 9. So 9 equals 9, gets a check. For my graph, I'm going to put one line. I'm going to call it 45, and it gets a nice closed dot. One more to look at. It says Mrs. Tally has 8 cups of pink lemonade in a pitcher. If she wants to give each person half a cup of lemonade, what is X? The total number of people that will receive lemonade. So when I look at this problem here, I have 1/2 X is equal to 8. I'm going to rewrite this. So I'm going to put, again, the X is my numerator. And again, I can do that because my numerator is currently 1. So X divided by 2 is equal to 8. Let's start algebraically. I'm going to build my t-chart, and let's isolate the variable. Let's get rid of what's bothering X. And what's bothering X right now is divided by 2. So the opposite operation would be to multiply by 2. What I do to one side, I have to do to the other side. My 2's cancel each other out. So what remains is X equals 8 times 2, which is 16. With my tiles, I'm taking one X piece and I'm dividing it into 2 different parts. Each of those pieces is worth 8. So this top half is worth 1, 2, 3, 4, 5, 6, 7, 8. And the bottom half is also equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So my entire X tile here is equal to 16. Going back to my check, I have X over 2 is equal to 8. I'm going to substitute in what I think X is. So 16 divided by 2 is 8. 16 divided by 2 is 8. So it gets the check. For my graph, I'm going to put one single line. I'm going to call it 16. And it gets a nice closed dot.